I'm Lawrence Denton, later named Larry when I came to Hanford, Larrydenton.
And now if you could tell us a little bit about how you got to the Manhattan Project at Hanford.
I got to Hanford via my father. I was living in Northern Idaho, working in a lumber camp, and I had an accident and cut my leg pretty bad. And I left the lumber camp and I called my father, who was down here working as a patrolman. And he said, they're hiring, so come on down. My father was here because he was a Marine in World War I, and the chief of security was Mr. Bubenter, his captain in World War I. And he went around into all the hospitals and got the able-bodied guys to come over and help him out until he could get his security forces going. And so that's the way I got to Hanford. And I was pleased with everything I saw here. The work was steady, and there was more safety than they ever thought of working in lumber mills, in the lumber camps and lumber mills. In fact, it was demanding that you work safely and did your job, didn't guess. You did what you could do, and if you didn't know what you were doing, you got somebody to help you. So, not being 18 or 21 years old, I was unable to come to work out in the reactor buildings or confined areas. I was assigned a clerk's job, which was called a shipping clerk, but I was receiving and issuing welding gases. We issued somewhere around 1 million containers of helium and oxygen gases. And I ended up living in the barracks at 52B in Camp Hanford. One of my roommates was a historical item in himself. He was a professional welder out of New York City, and they recruited him out here to teach the welders on the reactor, because they knew that when they made a weld, it had to be a good weld and last forever. And that was a gentleman by the name of Otto Lors. I went from the gas part to tearing down Camp Hanford and shipping off all the construction materials that was accumulated here, which was miles and miles of piping and valves and big milling machines that were to be used for milling the graphite for the reactors, which I didn't know anything about at the time. None of us really knew what was going on. We were totally amazed at all the stuff that was coming in. And the stuff that was going out was used, or never used. So we weren't producing anything. We didn't know what was happening. But the DuPont Corporation did everything to have peace and harmony in the camp that I could see. The one thing that I couldn't understand, there was a boy out of Northern Idaho who had never been around black people, and they had the black people segregated from the whites. That didn't make sense to me. In the Christmas time, when the postal department was overloaded, they took us clerks and asked us if we would deliver mail. And I got the colored barracks, and that confounded me more, why they segregated the blacks and the whites. But that was a fact, and they accepted it, and the whites accepted it. They built a big theater and big rec hall for our entertainment. We had outdoor theaters. They weren't too good sometimes in windstorms in the outdoor theaters. We had to sit there with goggles on to watch the movie, but it was something to do. And then we could walk up to White Bluff and get an ice cream cone. It was only 2 miles. But it was an amazing experience for a man from Northern Idaho, just come into a camp of 50,000 people going day and night. The big mess halls where you would go in, meal tickets were almost nothing. Wages weren't very much, but they were great then. $1 an hour, 10 days a week, or 6 days a week, 10 hours a day. It was a lot of money to us. And like I said, they insisted on safety. Then, as the construction ended, I did get transferred after I was 21 into fuel fabrication in the 300 area. And I was in on several experiments in improving the fuels down there that would be less fracturable and cause less problems during the irradiation process in the reactors. And I learned those processes, and later in 1948 was transferred out to the 100F area. And I got my operator's category, or what do you call it, assignment, and worked there for a year. And then I was transferred around to other areas. I went to B Reactor and was over here for a few months, and then went back to H area for the opening of H area, and then to D area, and then back to B area as a control room specialist. And then in 1960, I went into the water department and became supervisor of the filter plant in the river pump house in the head house. And then later on became supervisor of the powerhouse. I never did get into the electrical end of the power department. And that was a substation out here all of its own. And they had the Bonneville Power people transferred in for most of that. But I was, I guess, pretty much the relief supervisor for after my tenure here at B Reactor, and then I served in the other powerhouses in all the areas. Then when they started shutting the reactors down, my crew shut down D Reactor. We went out and locked the gate, and the next day we reported back over to BC, over here again. And in this time, in the 50s, we had to become certified. It was, I guess, recognized by the Nuclear Regulatory Commission as capable of running reactors safely. And I received the first reactor certification that was issued. And when the reactors, like I said, shut down, we were dispersed and had to recertify for other reactors. We recertified for C Reactor. And then when they were going to close it down, I went to N Reactor as a fuels manager. And then I transferred down to 300 area to do experimental work, back on fuels again. And I had the thoria compaction process development. And then they reassigned me to the zirconium production parts for N fuels, and we made the cladding and a lot of the smaller components, and supplied the production line with materials. Then I became manager of the essential materials for United Nuclear, which was all the helium for the reactors, and coal, oil, the chemicals required, and then I came out as manager of the or technician in the maintenance and surveillance, and became manager of maintenance and surveillance until my retirement.
Wow. Let's see, can we go back to the experiences you had early on then in the Manhattan Project? And you mentioned that you were involved in tearing down the Hanford camp. And was that at the end of the war then, after the war?
No, it was at 44.
44.
We left Camp Hanford in Christmas of 44 and moved to town and finished it up in the spring of 45, and before the war ended. Finished up our work as
demolition of the camp?
Yeah, it
Okay.
continued on, I understand, but it was all sold to different contractors, and they took care of the rest of it. In other words, the camp was sold on a bill of lading to them, and it was no longer government property.
What did you do on B? What was your job on the B reactor when you worked at B?
Well, the first jobs at B Reactor was just a regular reactor operator, and our job was to pull duty in the control room. We usually had an hour, depending upon the supervisor, an hour to 2 hours at the console, and then we had to do the other duties around the control room for 2 hours, like reading the panelnet board, taking the temperature maps. All this work was done by hand or mouth in the old Underwood typewriters at that time. So it took quite a while to read the tube pressures. The panelnet board, you had to read the one panel on graveyard shift, day shift, and the other one on swing shift. And you had to check to make sure that there were no changes. If there were changes in the pressures, you had to find out what caused it, whether it was a total change in supply pressure to the reactor, what it was, and then you had to follow the physicist's instructions on your rod configuration in the reactor to get optimum production, or follow the megawatt limits that you were required to operate at. And you didn't have an automatic calculator to tell you that, so you had to do your own calculations on a Marchand calculator here to tell what levels you were at all times. And then you had your the reactor Beckmans that if you got up to a level and you held the Beckman to a certain curve, you probably weren't going to change level. So you did have more than a feel, more than a thumbnail feel for where you were at. But you also had to keep track of the tube temperatures. And this was that old telephone keyboard there. The maximum tube temperature that I ever remember was 98 degrees centigrade. And the only way you could tell what you had was just to go through the whole board and call off the numbers of the temperatures and have the other guy write them down. And you check the map, see where your heat spots were. The reactor would not raise at a constant level all the way across the reactor and up and down the reactor. You'd have hot spots in various places, and you had to readjust your control rods to take care of those conditions. Later on, when they got in Cold War, do you want to go into that? Cold War?
Let's stay on B for now. We can go, a little later.
Well, anyway, they got to pushing the power levels, and then we started having heat cycles where the heat would cycle around in the reactor, and we never really knew why, but it was a neutron production change, and that caused a lot of problems when you're trying to get total operating efficiency out of your reactor. When your reactor shut down, which was, if it was an unintended shutdown, and you couldn't find the reason, if the reason was explainable and it was safe, then you could start up your reactor, and they had a limit there. You could raise your power level 15-second periods, and what that meant was you could double the power level in 15 seconds. Because the reactivity would be going away from you in that instance. In a cold startup, you had about a 30 to a 60-second period startup, but that was safe because you knew the xenon effect was going to get you. And what the xenon effect was that when your the reactor was first started up here in B Reactor, they were operating around, I guess it's somewhere around 100 megawatts, and they started celebrating. And then the operator started complaining, I'm pulling control rods and nothing's happening. And they went into big disappointment, and the reactor died. Actually lost all reactivity. And they got Mr. Fermi, I guess, into that room there behind me with his slide rule, and he was in there for a few hours, and he came out with the answer that the old girl just laid down on us, and she's coming back. She's had her pups, and she's coming back. And getting on her feet, and we were recovering here for too long, and so they just kept the rods out and sit here and waited, and they had the affirmation that the reactor was starting back up. So he called that the xenon curve, and so we had to they had to figure out ways to get around that, because that was a loss of production. And so they developed enriched metal, and they would charge the reactor with enriched metal, and then they'd put in poison splines that they could offset the enriched metal. And when you get up to the turnaround period, which was a xenon curve, then they'd go out and pull the splines out and maintain our level without a shutdown and just keep operating, and we could go into maybe whatever the operating period would be, 30 days to 45 days. It wasn't real long in any instance because your metal would reach maturity. And not total, but certain tubes would reach maturity, and then they'd go up and discharge those. You'd shut the reactor down and lower the water pressure after the reactor cooled down. And the reactor was built with redundancy. Everywhere you looked, everything was fail-safe in there as far as the reactor construction was concerned that I could see. The water supply was abundant, and it was in the 190 building across the street, and it was stored in 4 big wooden tanks, about 1 million gallons apiece, and they were elevated to the height of the top tube of the reactor. And the only way the water could get out of the reactor was to go in at all points in the front and escape up over the top, which they called a crossheader or overflow discharge into a downcomer, which accumulated water from both sides and out the rear. And if the water supply failed, they had a steam backup system, and before that they had 2 300,000 gallon high tanks, one on each side of the reactor. And the supply line check valves would close, and the high tank valves would open. Mason-Nealon valves would open, and allow water into the reactor until the last ditch system could get online. And that was supplied by steam turbines from the 190 building. The four-boiler powerhouse had a turbo generator that would hold the electricity up for them to get their steam up and get their controllers turned over. And then the 190 turbines would come on. And another thing that I failed to mention, that in the event of a water failure, the 5,500 horsepower turbines in the electric turbines in the 190 building had 2-ton flywheels, so that when you do lose your water pressure, they would continue to supply the water until the high tanks could come in and take over, and then the last ditch would come in. And the last ditch system was not filtered water. The water plant supplied 3 types of water: the processed water, potable water, and system water, which they used for a little bit of everything. And the Hanford water system was unique. It was developed at Hanford, and the filter systems had 12 filters on each reactor. And it was big egg crate design filters. And they had big boulder ceramic balls in the bottom of these egg crate positions. Okay, the construction camp was phenomenal as far as I was concerned. It housed 40,000 construction workers in barracks, another 10,000 in the trailer camp, and people that came from off the local towns around to work here. They had no facilities really to take care of things like this, so they brought in railroad engines and parked them along the railroad track. The Milwaukee Railroad was extended down into the town of Hanford, and the barracks were heated by steam, and these railroad engines provided the steam for the heating of the camp. We had a hospital. I think it was a 60-room hospital. We had a big administration building, men's barracks and women's barracks. Women were segregated from the men, in both cases, blacks and whites. And we had a grocery store, and like I said, we had that big rec hall, and we had some of the best orchestras in the world that came in, entertained for us. In fact, in 43, Kay Kaiser came in and gave us a show, and in 44 he came back and he said, "I can't believe this." He said, "It was sand and gravel and wind when I was here last time." And he said, "The only thing you've got now is all this darn safety equipment." And he had on the toe guards and the shin guards and the clothing that they wore and the mask. And that was typical of DuPont. Safety was the most important thing, as far as I was concerned. The mess halls, the tickets were cheap, and you go in there and sit down, and if you emptied a platter of pork chops, you just held the platter up, and a waitress would come by and take it and bring you a new one. And the best food in the world, it was Olympics catering, I guess, that the Olympics commissary that provided. They had big rec halls, and of course, when you got rec halls and beer and construction people, you're going to have problems sometimes. One time I had to go over to get a bunch of bill of lading signed for the material that was leaving the project, and I had to go past the rec hall. The fire department was over there with their fire hoses washing the construction workers' hard hats and all right out into the street. So they could stop fights. But it was an experience that exciting to me.
There were windows that were hinged. in the mess hall, and apparently I've heard both that they use the windows, open the windows and throw tear gas in to break up fights. We've also read they use the windows so they could quickly throw out rowdy people out the window.
I'd never heard that one. I wouldn't be surprised at anything, but not in the mess halls. I never saw a fight in the mess hall.
The rec hall, maybe?
The rec hall, yes, ma'am. The hard hat guys would come in there, and they still come in from work. They still had the spud wrenches and everything in their belts, and they would each take a pitcher of beer instead of a glass, and so it didn't take long to get out of order. And then when I came out of there that night or past there, I was going back to my room with these signed leadings. I had to get them signed by the railroad man that was in here, and over his barracks. And I stumbled over a bunch of guys playing craps out in the street. There were a lot of illegal gambling going on. Of course, the patrol was around trying to break that up when they could. But no, it was a fast-moving life.
And why did they decide to bulldoze it down?
They didn't really. They tore it down. They took it and they salvaged the lumber. They shipped the most of the lumber off to different sites around the country. Like I remember one place that I shipped a big milling machine to go overseas someplace with a big milling machine to Port Hueneme, California. I shipped stuff to Mississippi. We had a lot of Army and Navy storage facilities around the United States that we shipped stuff to. But the the barracks mostly were dismantled by contractors that bought them. And I had heard that they'd go in and bid on just the air conditioning systems or something that they wanted down there and get the rest of the building for nothing. They had built a 130-room hospital that was fully furnished, never occupied. And that stuff was all like categorized that. And I don't know whether that went to Bethesda, Maryland, went to someplace back east. All the equipment, the cots and the mattresses and all that stuff. So they didn't come in and bulldoze the city down until after the usable material was taken. Some of the barracks were made into barracks downtown, and some of them were made into Camp Hanford that went to 300 area, or below 300 area, where Battelle Buildings area is now.
What happened to the morale in the camp? I mean, what was with the morale in the camp? Did people have any? First of all, did people have any idea what they were doing here?
Working their tails off for a good check. They had no idea. I hadn't met anybody yet that knew what was going on. Mr. Rector said he knew, but I don't know. He was machinist of the graphite. But I don't know. Even Mr. McCullough didn't know, and he was Beckman developer. Sure, somebody had to know, but I don't know. There were lots of stories about Mr. Church being a god. He was the DuPont manager here, and he, because of his status and wariness about what they were doing, I understand they made the reactor work. It was designed for 1,500 tubes, and he didn't think that that was enough, and he wanted it expanded. And because he did have it expanded, it was a fissionable product. And that was his thinking all the way through. If there's a safe way to do something, think of two ways to do it safely. Fail safe was his motto, I guess. And that's what I found here. And the accumulators here are just in the room next door. In case of an emergency, lost your power, and the rods wouldn't go in, the hydraulic rods, those accumulators would drop and force your rods in for control. Your vertical safety rods tangled on the first drop that they tested, and he stopped production until they construction until they got some kind of a winch that would control a drop, and they got electromagnetic winches in it, and added on to the height of the building, and those winches could control the drop of the vertical safety rod to get it within a time limit to prevent a criticality event. Then he said, what if those things don't go in? And then they wanted some kind of a backup system. It's the third system, he said. So they made 4 big tanks up there and filled them with boron carbide solution. And they put thimbles around the holes for the vertical safety rods to go in, that the chief operator in here could pull this rope and open these valves and drop this boron carbide solution into the reactor thimbles. Well, that was real good for a few years, but then because of the ruptures and the moisture got into the reactor, those thimbles rusted and began to leak. And then they was leaking hot gases out in the building, so they got rid of those and developed the Ball 3X system, which was replaced the third safety system, so that there were hoppers around the rods, and this hopper door would open and drop the Ball 3X balls in. The original startup of the reactor, they had helium as a total heat transfer for the graphite system, and it was a 115 building out back that circulated the gas through the reactor. Each tube bearing block was chamfered so that the gas could be forced into the reactor in the front and go through these channels to the back and leave the heat and transfer the heat. And once they discovered trouble discharging a tube in the far side, and so they got to borescoping and found out they had distortion. The graphite was growing, which was a grave concern. And so they shut B Reactor down for a short period of time and kept D Reactor operating, and they introduced CO2 gas. And they mixed about a 50-50 mixture of CO2 and helium, and that stopped the growth of the graphite. And in fact, it did retrieve it a little bit. And so they continued using CO2 and helium through the whole process. In about 1949, I think the government took over the control of helium and started putting restrictions on helium. Before that, the helium came in here so dirty we had purifiers over there, and we had to clean it up. But once they got the helium storage in Keys, Oklahoma, and Amarillo, Texas, and they started getting clean helium, and we got it in cars, and it was good stuff. We didn't have gases or contaminated gases any longer. But we did always had things to be worried about, and we got inert gases around the building at high power levels, and they couldn't figure out why, because they knew that they had enough airflow around to discharge the gases in the stack, but it wasn't happening. So one of the radiological engineers said, well, we need to control it. So they went out to the work area in front of the reactor C elevator and dropped a curtain, made a great big curtain that dropped down to force the air down and up the front of the reactor and out, and that took care of that problem. In later years, they had to build a better purifying system for the air instead of just going straight to the stack.
Okay, hang on a second.
Okay. Okay. What did people know? I mean, was there a lot? What did people know about what they were doing?
Well, they were experts in their field of welding, concrete, construction, and they knew how to follow blueprints, and that's what we came and did. As far as I could interpret your question, the only effect you had out here was your terrible windstorms. There would be hundreds of people leaving in a windstorm, and other people come in and take their place. But they had to be professionals on what they were doing to machine the graphite to make a block the size that they have, less than, 1/16 of an inch tolerance on the whole block of graphite. So these people did this with carpenter tools. They didn't have anything made to machine graphite with. And the concrete people were the same way. They came in and built concrete plants. They actually built batch plants right here on the project. And this is what was so amazing. You go past a place one day and there was nothing there. The next day there was an industry going. And they had what they called the central shops up on the bluff up there towards the 200 areas. We delivered some stuff up there one day and it went back the following Monday and it was gone. They moved it down to White Bluff area. The whole thing was gone. There were the shops, the gas station, it was all gone. And things just moved around here. So the people they had in here were nothing but miracle workers, really. That's my synopsis.
Now, was there a lot of surprise when they found out? Because at some point the bomb was dropped and they found out what was going on. Were a lot of people surprised?
Absolutely, absolutely astounded. Yeah, I was at that time I was in a ditch, cleaning an irrigation ditch down by Chief Joseph or Carmichael High School, and that was E-Day, and when they blew the whistles and I came out.
Yeah, when they dropped the bomb.
When they dropped the bomb, it was the same thing. We were surprised. Hanford, we were all proud, very proud. We didn't have a bit of shame. And that's when they named the high school team the Bombers. I don't know anybody that was ashamed of it. We were ashamed of the killing that had to be done, of course. We were humanitarians. But our boys weren't going to go through any more of that.
So, I mean, were there a lot of people going, aha, I knew that was what was going on? Or were they
No.
just incredulous?
Yes, it was, like I said, it was a surprise. Very few people, and I suppose up in the DuPont end of town, they all knew. But down where we lived and where we worked, I don't know anybody that even had a hunch. I thought because DuPont was in here, it had something to do with explosives. I had no idea it was going to be anything like that. But we couldn't figure out if it was explosives, why they weren't bringing stuff in here that looked more like explosive material.
But you were working on the B Reactor, right? During the Manhattan Project. Do you think there was an attitude among people that, you know, that we're at war and we're just going to keep our mouths shut because we're good Americans? Or how do you think that worked? There had to be some patriotism involved or something.
Well, absolutely, there's patriotism. Yeah, we even bought a bomber, but we contributed a day's pay to buy a bomber. They had rallies, E-Bond rallies around, and I guess we just followed the DuPont attitude. We're in the war. We're going to do our effort, whatever it is. No, I know I do sound stupid, but I was stupid. I didn't know what was happening. And I don't know anybody that did.
When you said there was a DuPont end of town, what do you mean by that?
Well, up what they call Hunt Point, along the river, there was a section of housing that the DuPont people lived in, and the high Army officials lived in that particular area.